Hey guys, so let me apologize right now for the construction that may or may not happen. It's going to be annoying if it happens, okay? So 4.3, relating functions and their derivatives. This is a lot of like taking what we've already done and just kind of putting it all together, and then also, you know, doing similar things, okay? So realizing that this is all true. So the notes really, like for this part, it's stuff that we know, okay? So we're just like reiterating certain things. So when f is increasing, this is f prime, this is f double prime. When f is increasing, which one of these, like what do we know about, you know, first derivative versus second derivative? So f prime is positive. So it's written this way, and you know, that's like mathematically, that's how you say positive, right? When f is decreasing, when you're going down, when the slope is negative, then that means that f prime is negative, okay? So the slope is negative. This is slope is negative, okay? So decreasing means, you know. All right, so yes, there is construction. Concave up versus concave down. That has to do with the second derivative. So concave up means second derivative is positive. Concave down means second derivative is negative. We know this already. All right, this one is a little bit weird, so we want to think about this for a second. A local max is when f prime goes from positive to negative. We draw that little number line and we test out the numbers and we get a positive and then a negative. Now we know this is a local max. It is also when at a point we have something, we know that this is like a zero slope, okay? So if f prime is 0, then this would also be true for a local max, okay? So I said or, but really like this would also be true. So f double prime is, think about a max. For a max, it might look like that. What is the concavity? Concavity is f double prime. Concavity is down, so f double prime is negative. Okay, so I said or, but really it's like and. Okay, so it's an and situation. I think, oh, on your notes, yes, it says also. All right, and then for this, so a local min is when, you know, your first derivative changes from negative to positive, and then this is true. So local min, think about this, right? Isn't this a local min? So isn't this concave up? So also we have concavity that's going up, okay? And then inflection point. So inflection points, there's two cases. Do I want that? Yeah, all of it. So there's two cases. So for inflection points, you can change from concave down to concave up, or concave up to concave down. Those are both inflection points. So you might see something like this or something like this for f double prime. And then what's also true is that for an inflection point, f prime changes from increasing to decreasing. How come I say f prime is changing? Because f prime, the slope of f prime is f double prime. So if the slope of f prime is changing from positive to negative or negative to positive, then that means f prime is changing from increasing to decreasing or decreasing to increasing, right? Because what does decreasing mean? It means it's going down. So that has to do with slope being negative and then slope being positive. So when we see increasing and decreasing, we're thinking about the slope of whatever we're talking about, which is technically that f double prime in this case. Okay. So those things are just like, hey, these things are true. We know this though. Okay, given f, how would you graph f prime and f double prime? So we've done this part and we're going to continue. So how do we get from here to here? How do we get from here to here? Okay, so it's just like another step. All right, so what would we do to graph f prime? The first thing we would do is we always look for our zeros, right? Because zero slope means we can put points over here for f prime. Those are our points on the x-axis because we have a y equals 0 for f prime where there's 0 slopes. So at A and C and E, I have points. At A and C and E, I have points. I know you can see through this, but you know, I just didn't want you to yet. So I have 3 points here at A and C and E. And then this is increasing to A, decreasing to C, increasing to A. That means that this is, in its own graph, positive, negative, and positive. So positive until I get to A, negative between A and C, and positive between A and E. And then after that, it's negative again, so it's negative slope. So see how my F prime is down here, negative for F prime, okay? How would I graph F double prime? I would do the same things. Actually, I would do the same thing, and I would go from here to here. So where do you start? You start at the zero slopes. So at B and D, I would have points here. For B and D, I have points on the x-axis. And then I can tell it's negative slope until we get to B. So this is negative until we get to B. And then it's positive slope until we get to D. So negative means below the x-axis, and then we're going to be above the x-axis, and then below the x-axis after D, because that's a negative slope. So below, above, below. And then just like we've talked about before, notice that when we take a derivative like this is some sort of parabola, right? It looks like some sort of parabola. This is an x squared. What did it come from? It came from an x cubed. What did that come from? That came from an x to the fourth. And x to the fourth has 3 turning points. It has 3 like humps, right? Whatever you want to call it. And then we take a derivative and it becomes an x cubed. Now it looks like an x cubed. And then we take a derivative and it looks like an x squared. Now it looks like an x squared. Okay, so it's always going to be like 1 degree lower. And if you go the other way, it's 1 degree higher. So it's going to have 1 extra like turning point, I like to call them. Okay, okay. So then what about, this one's kind of weird. I need 2 sheets of paper. How about this? So, you know, don't just try to like look through and copy. But if you have an F prime, how would you go backwards? How would you go forwards? Well, we just went forwards, right? So what would you do to graph F double prime? So F double prime, that's easy. So we would just like keep doing what we were doing. So at 1 and 3, I have points at 1 and 3 on the x-axis. And then it's negative slope, positive slope, negative slope. So my F double prime is under, over, under. So it looks something like that. Okay, what's this going to look like? All right. So when I go backwards, I think about, all right, let's see. I have, sorry, I got to think. So I start with my zero slopes. Okay, I have a max at 0, and then I have a min at 2, and then I have a max at 4. So that's what I know. Okay, I don't know about the y-axis or anything like that, so I'm not sure about my like where my x-axis is. It could be up here, down here, but all I know is I have a positive slope and then a negative slope and then a positive slope and then a negative slope. So positive, negative, positive, negative. So it's going to look like an M. That's what I know. Okay, this is going to look like an M. So then I know that this was, again, a max, a min, and a max. So I draw it above, below, above, somewhere, like somewhere there. And then what happens is I have these inflection points. So these inflection points I know at 1 and 3, so at x equals 1 and x equals 3, concavity changes. So first my concavity is negative, so I make sure to draw it going concave down. And then between 1 and 3 my concavity is positive, so now I have concave up. And then after 3 my concavity is negative, so concave down. But I have to follow the points that I have for maximum, minimum, maximum. So max, min, max. And then I have to have my concavity points, my inflection points. Okay, so here's my inflection point where it changes to concave down to up, and then down, or sorry, up to down here. Okay, so I need all of those points. I don't know what the y values are here because I don't know enough. All right, okay, so now we're going to draw. I love this part. I will say I love this part. And sometimes you guys don't love it, but I love to draw things in general. Like I actually like to draw, okay? So I'm gonna hide a little bit. Okay, so they give you all of this stuff and you're supposed to draw a function. So I should look for a pencil, darn it, but I don't have a pencil. So you're gonna use a pencil while you're drawing this, okay? So here's what you're gonna do. I want a pencil because I wanna be able to cross things off. because I don't want to do all of this in the order that it's in. I want to do it in my order, which is like the best order, okay? So like I want to do it so it makes sense. Okay, so sketch all of this information. I want to start with if I have like a limit or if I have an x value, I want to start with that. And then I want to go to f prime, and then I want to go to f double prime. Okay, so I want to go in that order. So f prime, and then f double prime. So before I do this, I want to do this one. All right, so how do I know how to draw it? I look over here and I look at the important parts. So I have a negative infinity, I have a 0 that seems important, and then I have a 3. So a 0 and a 3. I definitely need from 0 to 3. And then I don't know what happens to my y-axis, but I have it like somewhere here. So the x-axis is in between. And then I'm going to go a little to the left and a little to the right. So just so I have enough space, I know I need 0 to 3. And then here it says 3 to infinity, so I probably need to go to the right a little bit as well. Okay, so I'm going to start with the limit first, because that's not a first or second derivative, so I'm going to start with that first. And it says at 3, the limit is negative infinity. Okay, so if it's negative infinity, that means that we have at 3, I should label this. That's 3, that's 2, that's 1. Let's put a 1 and 2 here just in case. So at 3, I know that there's a vertical asymptote, because without a vertical asymptote, how would I have a negative infinity? So it says a negative infinity. That means the left side and the right side, I should be doing this in pencil, are going like this and going like this. Okay, so I'm using a pencil because I'm just sketching and then I have to make it pretty after. Okay, so I know it's something like that. So I would cross that off with my pencil. I'm done with you. Okay, and then I go to an f prime. So f prime says f prime of 0 is 0. All right, so at 0, I have a slope of 0. All right, so at 0, I have a slope of 0. My graph is going to do that. That's all I know, okay? Okay, cross that out. I'm done with it. Okay, f prime of x is negative for 0 to 3. So between 0 and 3, what's f prime? I have to translate it in my head. The slope of f is negative. So slope being negative from here to here means we're going down. Oh, this makes sense. So it's going to look something like this. Okay, that makes sense. I like that. Okay. And then I cross that off. Okay, that's done. I'm going to go to an f double prime. For f double prime, when I'm, from negative infinity to 0, my f double prime is positive. So my concavity is concave up from negative infinity to 0. So I'm concave up from here to here. Concave up. Well, I can go like this to go concave up, or I can go like this to go concave up. I think it's going to be like this, because if I go like this, that's not a slope. That's like a weird corner thing. Okay, so that something weird happens there if I go like that. But concave up, I can probably go like that. So I'm going to just, I think it's like that. I'll fill it in a little bit, okay? But I think it's like that. Okay, I'm going to cross it off. And then concave down for 0 to 3 and then 3 to infinity. See how it's like not at 3? So because there's something weird happened. So concave down. Oh, this is already concave down, so we're good. And then this is concave down on the other side. Okay, so concave down, but then it's going in this direction. So maybe something like that. And then everything else, I think everything else is good. I'm going to go like that. I'm going to show you guys what I had here. Yeah, something like that. So, right? Kind of makes sense, hopefully. Okay, let's do the other one. So for the other one, I'm going to start, oh, look at all this information. I love it. I love it. It's not like a, oh, bad. It's like a, oh, good, yes. Okay, so I'm going to look for some numbers that I can use. So I know I have a 1, a negative 1. I need a 1 and a negative 1. Oh, another, yeah, negative 1, 1. I have right here a 0. Okay, so I need these numbers here, so that's why those are in the middle. That's why I drew it this way. And then I also need a -4, 1, negative 1, 4. Okay, I need to go up 4. Oops. 1, 2, 3, 4. Okay. So here's a 1, here's a 4. Yep. So I think this graph will do. We'll test it out. If we need to make it bigger, we make it bigger. Okay. So I'm going to start with, I'm going to look through my f. So here's an f. F of -1 equals 4. All right, I'm going to cross that out. I'm going to draw that point. -1, 4, 10. Okay, so it's crossed out. I got my point. F of 1 equals 0. So f of 1 equals 0. I'm going to cross that out. That's a 1, 0. I got another point. Okay, I'm doing okay. I'm going to look through and I'm going to look through for f primes. So all my f's are gone. Now I'm just going to do my f primes before I go on to f double prime. So f prime. F prime of -1 equals 0. So f prime of -1 equals 0. So here there's some sort of slope. Actually, I don't know where it is, but the slope is 0. So it could be like here, it could be here, it could be here. I don't know. Okay, but the slope is 0. Okay. Okay, so I don't want to cross it off yet. I'm going to leave it for a second. F prime of 1. Oh, wait, what just happened? Oh, -1 is here. Duh. I am not doing these notes again. Okay, -1 is here. I already have a point. So 0 slope. That's what it does. Okay. And then f of 1. There we go. F of 1 does not exist. Oh, something weird happens here. There's no slope. So this is not a 0 slope. It could be a vertical tangent. It could be a cusp. It could be a corner. Okay. So I'm going to leave that. I'm not going to cross it off. So this is crossed off. I'm not going to cross this off. All right. The next one says f prime is negative. So my slope is negative between -1 and 1. So between -1 and 1, my slope is negative. Okay, that makes sense. So it might look, I'm thinking it might look something like this. I might change it if I have to. Okay. And then f prime is positive everywhere else. So from -infinity to -1, I'm positive. And then from 1 to infinity, I'm positive. Okay. So for now, if this was a pencil, I would lightly go like this. I would lightly go like this. Okay, if this was a pencil, I know it's not, but it's going to look something like that. It's going to follow that, you know, slope, okay? And then I already did this. Okay, my last one. Okay, concavity. F double prime is negative, concave down, when we're not at 1. Everywhere except for 1, we're concave down. Okay, I can do this. Concave down, so I just follow what I did, but it's concave down. Concave down. I can't go down this way. Okay, be careful. You can't go down this way. How come you can't go down this way? Because it says that the slope is positive. F prime is positive when we're to the right. So it keeps going up, technically. I know it makes it look like I'm going like in some other direction, but it looks like that. Okay? So it keeps going up and it's concave down. Everything's concave down. This makes sense. I didn't cross this off. This makes sense because it does not exist, right? That's like a cusp issue. It looks like a cusp. Okay, so let me see. Yeah, it looks something like that. There we go. Love those. Guys, I love those. Okay. And then this is review, but you need to know it, and some of you might not remember it or know it. So let's look, okay? Reminder about end behavior, turning points, multiplicity. I love end behavior. It makes things so much faster, okay, versus turning points. So when you have y equals x, it's a line that goes like that. When you have y equals x squared, it goes like that, x cubed. So you should know what these look like in general. Y equals x cubed looks something like this. These are all positive coefficients. When you have a positive coefficient, you end up. See the arrows at the end going up? So you always end up at the top. So up means up here on the right if you have a positive coefficient. If you have a negative coefficient, you end down. So the negative coefficient makes it so that on the right side you end down. And then you know what this looks like. that negative x, y equals negative x, you know what a negative parabola looks like. This one looks like that. So what you start to notice is with the turning points, if you have a degree 1, there's no turning points. Degree 2, you have 1 turning point. Degree 3, you have 2 turning points. So you don't have to have 4 turning points for x to the 5th, but you have to have 4 turning points or 2 turning points or 0 turning points because you have to end up. So you can have up to 4 turning points. You can have up to 3 turning points. You can have up to 2 turning points, okay? And then multiplicity. So if you don't remember multiplicity is, I'll show you. So multiplicity is the power right here. So if you have an even power, then at x equals 1, you're not crossing, you're touching. But then here the power is 1, that's an odd power, you're crossing. You're crossing. So when we make like a little number line, that's what I'm talking about with the number line. The number line is really like an x-axis, right? Okay, so we're going to sketch this using multiplicity and behavior. So this makes life so much easier for your little number lines for f prime and f double prime. Okay, we'll see that later. Okay, so what I'm going to do is, well, I already drew it, but what I'm going to do is I would draw my number line. I have a 1 and I have a -2. So -2 goes here, 1 goes here. And then what I know is it ends up. So it ends up like this. And then what happens at 1? It's even, so it touches. So it ends up and then it stays there, it just touches. What happens at -2? The multiplicity is 1, so it crosses. So this is going to cross. Okay. This ends up, which is how I started it, and then it touches, and then it crosses. And then what does, if I were to multiply all of these together, I would get y equals x cubed. What does y equals x cubed look like? It looks like that. Is that what I have? Yes, I am right. And then what are these minuses and pluses? I can tell right here I'm under the x-axis. So over here I'm negative, over here I'm positive, over here I'm positive. So that's going to help us making the f prime and f double prime. Okay, so this is a reminder of multiplicity. Okay, another one. So like this, ends down. So I would have, what would I have? Ends down because there's a negative in front. So I have a -1, a +2, and a +3. Okay, this ends down. I'm going to go like this. And then at 3, what happens? Oh, it touches because that's even. And then at 2, what happens? 2 crosses because it's odd. It's a 1 power. And then at -1, what happens? That's odd. So it crosses. And then I should have a negative and a positive and a negative and a negative. So if this was f prime, it's not. But if this was f prime, I would have 1 local min and 1 local max. And this would not be a local min or a local max. Okay, so that's how it got drawn. Okay, and again, if you multiplied all of those together, you would have like a y equals 3 + 1 + 2 is -x to the 6th. -x to the 6th goes like this. And then, is that right? 1, 2, 3, 4, 5. Yeah, so up to this many. So it could have up to 5 turning points. And this one only has, 1, 2, 3, 4, 5. And this one only has 1, 2, 3. That makes sense, okay? But you can see the beginning and the end behavior is mimicked with this, okay? Okay, the last one, you're gonna try it out, same thing, try it, and then you get something like that. Okay, so this is when we actually use it. You ready? So number 5. Find all critical points, inflection points, and then graph. Graph it very, 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 very neatly. Okay, so we are going to look at this, and I know that this ends up, and I know it looks something like that. So I already know in my mind it looks something like that, okay? So the first thing you're going to do is find the first derivative, and then solve for 0, and then make your little number line. How can you make this number line very quickly? There's 2 ways. One is multiplicity and behavior, but the other one is you look at this, and this is an x squared, and x squared goes like that, right? It's crossing at 0, -2. So it goes like this. So positive, negative, positive. So if you just know what that looks like, that's a positive parabola, then you can draw your pluses and minuses very quickly, okay? Or if you don't know, you can use multiplicity, or you can plug in. Okay, and then you know that this is a max and this is a min, because positive to negative, negative to positive. All right, so we're gonna do our second derivative to get inflection points, and we get something like that. We can see right here, there's an inflection point. It goes from negative to positive concavity, okay? So I'm going to start drawing. So, I first list, okay? So you list everything. So can you list, actually, list all of your, increasing, decreasing, whatever. List them all, and then check them. So when you list them, your increasing, decreasing, those are intervals. Your concavity, that's intervals. Your local max and your local min, those are points, because you're going to have to draw it anyway. And then your inflection point, that is a point. You're going to have to draw it, okay? And then you go through and then you literally draw it. So you draw an x and y. You go to -2, 8, and then you draw all of this. And then you get something like that. And it should make sense with this, and it should make sense with what you thought it was going to look like, which is an x cubed. Yes, this is true for all of these, and it's true for the original. Like, it has to make sense. All together, it should make sense, okay? And then, what's the last part? Oh, I just listed. So I listed those points, like how I got them, right? So that's all I did. Okay, so really, it like ends here. All right? Okay, give it a try. See you later. Good luck.